All right, on this problem, we are solving radical equations that have radicals in them. The first example is the square root of 7x minus 10 equals 12. The second example, we're going to solve the square root of 6x plus 1 plus 2 equals 7. And the last example, we will solve 1/2 times the cube root of 12 times m plus 4 equals 2. You know, we're solving these equations, so when we're finished with each one, we're going to have the variable equal to a number. And always keep in mind, the only way you get an answer as a variable equals a number is when the original question had an equal sign in it. It has to be an equation or you can't solve it. Okay, the 4 steps we're going to use to solve these equations with radicals. Step 1, we're going to isolate the radical. Step 2, we're going to eliminate the radical by raising both sides to the power of the index. Step 3, we're going to get rid of the parentheses. And step 4, we're going to solve the equation, and then always look at step 5, checking to make sure your solutions are good. That's very important when you're solving radical equations, because sometimes your answer is bad because it violates certain rules. Okay, so let's start with the first problem, solving the square root of 7x minus 10 equals 12. First thing we want to do is isolate the radical, but that's done. Step 2, eliminate the radical by raising both sides of the equation by the power of the index. So the entire left side raised to the second power and the right side raised to the second power. And again, I'm just reminding you here that we don't have to worry about the absolute value bars for even index roots here. Step 3, well, we're going to cancel the square root and the second power because they are inverse operations, and it leaves 7x minus 10 equals 144. Now we're going to solve the equation for step 4, move the negative 10 over by adding 10 to both sides, and that leaves 7x on the left equals 154 on the right. And finally, eliminate the coefficient of x by dividing both sides by that coefficient 7. That gives us x equals 22. And don't forget step 5, where we have to check our answer by plugging x equals 22 back into the original equation, simplifying both sides separately, and making sure that they're equal to each other. So under the radical sign, we have what? 154 minus 10, which is 144. Well, you know what the square root of 144 is. That's going to be 12. So the left side is 12, the right side is 12. Yes, this x equals 22 is a good solution. It satisfied the equation. Next example, step 1, isolate the radical. We have to do that. We got to skip it last time, but here we have to move the 2 over to isolate the radical alone on one side. Square root of 6x plus 1 equals 5. Now step 2, eliminate the radical by raising both sides to the power of the index. For the square root, it's the invisible 2 that's in the hook. That's the index. So square both sides. Eliminate the radical on the left side to get 6x plus 1 equals the right side, 25. And now solve for x. Isolate the variable term, 6x, it equals 24, and then eliminate the coefficient by dividing both sides by 6. Your answer is x equals 4, but you have to do step 5. You have to check to make your solution is good. So plug in x equals 4 into the original equation, simplify both sides, and see if they're equal. On the left side, we end up with, let's see, the square root of 24 plus 1, and then add the number 2. Is that equal to 7? Well, it's the square root of 25 plus 2. What is that? That's 5 plus 2. What's that? That's 7. 7 does equal 7, so yes, it's a good solution. If it were bad, we'd have to throw it away, but it's good. Last problem, step 1, isolate the radical. Well, the reason it's not isolated is because there's a 1/2 factor. So we get rid of the fraction by multiplying both sides by the LCD, which is 2. So 2 times 1/2 times the radical on the left equals 2 times the number on the right. 2 times 1/2 cancels, and it just leaves 1. 1 times the cube root of 12m plus 4 equals the right side 4. Step 2, we're going to eliminate the radical by raising both sides to the power of the index. So in this case, it's a cube root. We're raising both sides to the third power. The cube root and the third power cancel each other, and we're left with 12m plus 4 equals the right side. 4 times 4 times 4 is 64. Last step, solve for m, move the 4 over. We get 12m equals 60, then divide both sides by the coefficient 12. We get m equals 60 divided by 12, which is 5. And finally, step 5, check your solution to make sure it's good. Plug 5 in place of m into the original equation. So we have 1/2 times the cube root of 12 times 5 plus 4, and a question mark. Is that equal to the other side 2? That's 1/2 times the cube root of 60 plus 4. Is that equal to 2? That's 1/2 times the cube root of 64. Is that equal to 2? That's 1/2 times 4. 4 is the cube root of 64. Is that equal to 2? Well, yeah, 1/2 of 4 is 2. So 2 is equal to 2, which means our answer, m equals 5, is a valid solution. Yes, done. Very good. Very good, Anthony. It's very good.
I know that. I already knew that. That's a simple question. What's 2 times